Again, thank you everyone for attending the May 2021 Nova Software Quality Engineering and Automation Meetup. This event is normally held at Fannie Mae's office in Reston, but we have been holding these meetups virtually during the pandemic. I'll go over a few upcoming events that I want to highlight. First, Coveros is hosting a web seminar on whether Agile has helped or hurt testing. That'll be on Thursday, May 27th, 1:30 to 2:30 p.m. It will feature some testing experts, including Jeff Payne, Johanna Rothman, and Rob Saborin. I also want to note that the Agile DevOps West Virtual Conference will be held June 7th through 11th. There'll be a lot of great content and activities, including keynotes, tutorials, and over 40 sessions. Last but not least, as you may or may not know, Coveros and Techwell have a website called Sticky Minds that is a place for experts in the testing and test automation fields to post information about their work or upcoming or new trends in testing. So if you are interested in getting your ideas out there, please consider writing an article. You can find the submission guidelines at the link that I just included in the chat. With that, I think that's everything that I had to cover. So I'm going to turn things over to our presenter, Max Saperstone with Steampunk, who will be talking about page object model pitfalls. Max.
All right, thanks, Jonathan. You don't need to do a plug about like asking for speakers for next time or anything?
We have thank you for that reminder. We do have a speaker for our August meetup, but we will be looking for a speaker for our November meetup. So please let me know if you have a talk you're interested in giving.
Happy to do your job for you, Jonathan. You're welcome. I'm going to talk to you guys about page object model pitfalls tonight. Basically, now I'm not going to say don't use page object model pitfalls. Really, this is just not to use page object models. This is really just an idea to get into different design patterns that you should or maybe shouldn't use in testing, and to really put a little bit more thought into that. So if I can, there we go. Actually, let's go to the next slide. So really quickly, I want to introduce myself. My name is Max Saperstone. Technically, I guess my title is Technical Sales Consulting Manager, and I had to look that up because I use it so incredibly rarely. What it really means is I design a whole bunch of tech, whether that's on the DevOps or testing side, and then I try and use that to grow a new business for Steampunk, which is where I currently work. I've been working in the testing space for over 15 years. I started out doing manual testing on some ancient naval ship that actually I think ended up getting canceled, never even made it out there. But essentially, I was writing tests to try and simulate different system inputs, and the outputs that I got were huge, just chunks of binary data, like pages and pages of zeros and ones. And I very quickly realized that's not something that we can really reasonably verify with any sort of certainty. So I actually started writing scripting. And at that point, it was Perl. It was the only system that was available to us. And from that, I really just kind of rolled into automation. And that's really what I've taken as my main lesson in automation, which is to do things the easier, lazier way. So that's what I mean by the right kind of lazy, which is really to figure out how to make my life easier and everyone else's life easier as well. Most of what I use are open source tools, but it's not exclusive to that. And for about the past several years, I've really been working a lot more as a tech lead and as a test architect, really figuring out what the system needs, what the people need for the system, and then helping kind of design the right thing for all of that. So as I mentioned, I work for a company called Steampunk. And basically Steampunk is a change agent in the federal contracting industry, trying to bring new ways of thinking to our clients that are in the homeland, the federal, civilian, and the DoD sectors. We really focus a lot of our work on human-centered delivery and design intelligence. And that's actually really where the name comes from. If you think of Steampunk, the whole idea is the melding of machine and man. And that really is the goal of what we try and bring, which is this user-centered, user-focused design aspect into how you're going to be interacting with your application. And to me, I really like that, because one of the things that I absolutely hate about testing is I'll come up with a bug and I'll hear works as designed, or yeah, but that's a usability issue. We don't care about that. And the whole goal really of user-centered design is to make sure that those considerations are taken, are thought about initially, so that you don't end up at the end of the day with something that, yeah, maybe technically meets the requirements, but it is in, non-usable piece of garbage that no one actually wants at the end of the day. So that really is it. And so while I do a lot of their DevOps work, I'm still very heavily involved in testing for them, which is, for me, a whole lot of fun. So with that, I want to jump into giving you a quick background, basically, about what the page object model is. I didn't get any input from you all. I have no idea what your familiarity is, and that's totally fine. So we're going to talk about what the page object model is, what's good about it, what's bad about it, and then we'll jump into some other design patterns. Jonathan mentioned initially, if you have any questions, just to throw them in chat, that's fine. If you want to go off mute and ask me directly, that's fine as well. You're not going to be interrupting me. I would love to not just stare and talk on my computer for 40 minutes or so. So feel free to kind of ask questions, and I'll be happy to answer and deviate or do whatever we need to for this. I also have a tendency to get very excited when I talk and talk faster and faster and faster. So if I'm going too fast, you want me to repeat anything, just let me know. Again, throw something in chat, say something. Happy to kind of go over all of this, any of this again. Okay, and so with that, let's talk about what the page object model is. And so it's a design pattern, and it is popularly used in pretty much all test automation tools and frameworks. And the whole idea, the whole goal behind it is to create an object repository for web UI elements. And the whole goal of doing this is to try and reduce code duplication, and as a result, improve test maintenance. So this is, if you're familiar with your general design patterns, it's a composition-based abstraction of how we're going to be how we should be interacting with a given page or a given view. And it really is supposed to be the natural flow of kind of following certain good coding practices. So the goal is, under this model, for each web page of the application, there should be a corresponding page class. And this page is then going to identify all of the different elements that are on the page. And it may even contain different page methods, which are going to help perform operations on these particular elements. And so, you want to kind of name your methods as to what they're doing. So, if something, for example, is waiting for something to appear, for example, if you have a wait for login, you want to wait for your login, you want to wait for your submit button to be enabled, you would probably want to name your method wait for submit button enabled. So it's very clear, very obvious what everything's doing. And again, that's kind of the basis behind it. And the goal is, again, to be writing good code, because you don't just need to be able to find elements, you need to be able to perform actions on them, and you need to make sure that, that you understand exactly the state of your current page. The problem is that, when you start writing a lot of this code, when you first start off with your automation, you have a whole bunch of duplicated code. If you ever, at least if you're like me, when you start with writing some tests or writing with a new framework, you write one test and that looks great, and then you copy it and then you paste it in and you change one or two things, and you may do that 100, 1,000 different times. And what that means is, if there's any change in any of your elements, you have to change all 10 scripts, and it can be time consuming. It can be very error prone. And so the whole idea is to create these separate class files, which are going to contain all of your web elements and how you're going to interact with them, so that if you do have to make any updates, you can make those updates in one place. And again, this is what's called the page object model. It's supposed to make the code more readable, the code more maintainable, and the code more reusable. In addition to all of that, you may even end up breaking down your pages or your application even further. Maybe your pages are huge. Maybe you just have a one page, those nice fun, scrollable, single-page applications. And so maybe rather than having a different separate class for each page, you're going to have a separate class for each modal or each section. Doesn't really matter. The whole idea is you want to be creating an object repository that has a particular purpose. And the whole goal is to be very descriptive in absolutely everything that you're creating. So if we were to take an example of what this actually would look like, and as I mentioned earlier, we have code examples throughout this, all sorts of different languages. So hopefully someone will at least recognize something in here. But here's a Java page object model example. So over here on our left, we have our test class, our mytest.java, our public class may have all sorts of other things. But within this, we have one particular method with the @test annotation telling us that it is, in fact, a test. And you can see here a lot of things. And by the way, this is all from real code that I've pulled from all sorts of different repositories and projects that I've written over the last few years. Sanitized, of course. But so the idea is, we have this particular some test. The very first thing we need to do is we need to log in. So we create this new login object from going to our setup, navigate to, and we provide in the driver, we provide the URL. Next thing that we're going to do is we are going to log in. So we call login.login, we provide a username and password. Because this does provide a state change of the application, it's actually going to spit back a new object. Because after we log in, we're no longer on the login page, we're on the home page. It returns a new homepage object, which we're then going to call home. And then really for this test, very, very simple. We just want to make sure that on the home page, the welcome element, if we get the text from it, says welcome plus our username. A relatively simple test. But again, this is using our page object model. As you can see, we have objects, and you can probably look through this without understanding anything else and get a good sense of what's actually happening. I haven't looked at this code in a while, and I can still kind of walk through it and understand exactly what's going on. So this is our actual test, and this is one of our page object model classes, our login page.java that we refer to up here. So up at the top of each of your page object models, you're going to have one or more, probably much more towards the more, elements. And for each of these elements, what you're actually going to have within there is they're all going to be defined. And there's all sorts of different ways to define these. You can use find by annotations. You can use anything else. But for here, we have our find by. Is we're saying this element has an ID of sign in form username. And that's going to return back a list of all of these different elements. And I know what you're thinking. If it's an ID, you should only be getting back one element. You shouldn't be getting back a list. But as I said, this is real code that I actually wrote. And my developers had no desire to follow good web standards. And so there were 3 different elements on this particular page, each with the exact same ID. So we returned a list. Within here, we have our login application that we're actually going to be using here. So just like we called here, our login method returns back a new homepage element. So we provide the username, we provide the password, and what we're doing is we're essentially calling other methods within here. We're calling an accept and login, and we're going to click on that particular element, which would have been defined up here. We're calling another method, enter username. We're providing a username, which essentially just finds the correct username field and does a send keys with our username. We're going to do the same thing with password. We're going to click login, which is another method that essentially finds our login button and clicks it and probably waits for some such thing to happen. And then finally, we're going to return a new home page. This is fairly important if you're designing good page object models because, again, you want your page object model to reflect the changes and that's actually taking place within the application itself. And so, again, we're returning a new object because we're no longer on the home page, on the login page. We're now on the home page. And that is a very, not even simplified, but a small cross-cut look at what a page object model should in fact be. Before I jump on to talk about advantages, disadvantages of the page object model, any questions about what it is and what it actually might look like? All right. So that, as I said, I'm going to talk a little bit about the advantages. But the really nice and really the best thing about the page object model is the operations and the flows from the UI are are modeled in one place, and it makes it extremely easy to make updates, which makes maintainability and reuse extremely simple. One of the core ideas behind the page object model is that your flows and your operations in the UI should be separated from your verification. So that means that you're going to have a separate method for clicking a button than you would for verifying that a button exists. And you always want to keep these completely separate. And I'll actually talk about why when we get into another design pattern. But as long as you actually keep your flow and your verification, and your verification separate, it makes our code much cleaner and much easier to understand. The other nice thing is our object repository is independent of test cases. And so, as I said, for reuse, we can keep the same object repository for a different purpose with different tools. So for example, we can integrate our page object model with, let's say TestNG or JUnit or whatever framework, Java framework we're talking about for our functional testing at the exact same time as we could maybe be using something like JBehavior or Cucumber for acceptance testing. So completely different frameworks, completely different test structures, but we can still reference the exact same, essentially shared libraries of our page object models. And so our code then becomes a lot less, and it becomes much more optimized, again, because of this reusability that we get for it. Our methods, of course, as I mentioned, should have more realistic names, which then means that things can be much more easily mapped to the operation actually happening, which means it can be a lot better understood. And that overall standardizes how your tests are going to be interacting with the pages, which again makes maintainability very easy. For me personally, I am terrible about commenting my code. And even when I do write comments, oftentimes my comments are terrible. And the nice thing about following good patterns with keeping everything separate and naming things appropriately is when you come back a week, a month, a year later, hopefully you're not staring at something going, what the hell did I actually write? What is this actually supposed to be doing? And the page object model, if you're really following it well, provides a lot of help actually for that. Now, that said, there are definitely some disadvantages of the page object model, and that's what we're going to kind of be talking about and diving into for the rest of here. But the main issue with it is that ultimately what happens is you end up focusing on the page, the site as a whole. And when you have all of these methods and all of this capability in order to just reuse the same steps over and over again, a lot of times you lose focus on your subject under test. And what I mean by that is, well, let's say that I only care about one particular element on a page that I have to navigate 3 pages deep in order to get. Well, what that means is when I'm following the page object model, I'm probably going to be typing a lot of things, clicking a lot of things before I ever actually get to that one particular element that I care about. And that may not actually be the best way to actually verify something. But because all of this, this model exists, you're much more likely to utilize it. You're much more likely to make your tests much more complex and much less reliable as a result of it. The pattern, one of the big problems with it is it encourages you to prematurely design UI elements for reuse, meaning that if you're going to be using an element, accessing it, then you should be creating it within your page object model. And this really violates the Yagni principle. You ain't going to need it. And that's in case you're not familiar with it, so the programmer should not add any sort of functionality until it's deemed necessary. As a result of this, your page objects, they get huge and they get really difficult to maintain. And I say this again from personal example. I have seen page object models, page object classes that just have 700, 800, 1,000 lines to them, maybe with several hundred different locators on them, some of which aren't being used at all, and a lot of which are only being used once. And this creates a lot of code to have to go through, to have to maintain, and to have to figure out, and really just becomes kind of bulky and isn't great. So all these locators, all these groups, but potentially even unrelated functionality become extremely difficult to try and maintain and get through. And as a result of that, a lot of times you actually end up breaking the SRP, your single responsibility principle, which is, of course, that every module, every class should have responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. And most of the time, building out your page object model doesn't result from that. Because you would actually have to break this down into smaller page objects, like I was talking about. Even then, a lot of times you're still going to be violating the single responsibility principle, just because of the way that you really have to stay focused with that. And I don't mean to demean testers in any sort of way, but typically, my experience has been testers don't have the same development chops that developers do. That's why we're testers and not developers, and there's no problem with that. But even developers really do have a hard time following some of these principles of keeping good, strict code. And by following a model that doesn't promote this, you're much more likely to fall into a lot of these pitfalls, traps. So, when your actions kind of, they belong to two different pages, you get a whole bunch of different repeat, and your responsibilities just kind of start to stretch out. What you find is that they're not fully encapsulated. And again, as a result of this, you really lose focus, and your code gets much harder to maintain. Your page objects, a lot of times what I see is they try and fit multiple cases into a uniform interface. And as a result, you end up falling back on a lot of conditional logic. And in my personal opinion and what I've seen, conditional logic in your test cases is one of the worst things that you can do. Just because if you're writing a test, you need to understand the state that your system is in so that you can properly exercise it, so that you can have a deterministic result. If you don't understand the state that your system is in, that's when you throw in your conditional logic. But as a result of that, well, how are you sure that you really tested what you think you're supposed to be testing? And you may say, oh, well, it doesn't matter because of X or Y, or, well, we kind of expect both of these. But even if that's the case, how are you sure that you've gone down both branches? You really need to be careful as far as creating conditional logic. And again, this is one of the things that when you create these page object models, you typically end up building out. It can be avoided. It's just one of the patterns that emerges when you actually follow the page object model. The big thing, and this is what I'm about to jump into, is that page objects make the tests slow. And that's because they don't necessarily force, but they really encourage the tests to always go through the application user interface, which is the absolute slowest way in order to interact with your application. And again, this gets back to what I said before. Because you already have all this functionality that's written out, how to log in, how to navigate to this page, how to click these buttons, how to do X, Y, Z. The default is, well, let's reuse it because that's why we designed it that way. The problem is, well, if I have to click on a page and then, if I have to open up a page and then I have to type in a username, and then I have to type in a password, then I have to click submit, and then I have to wait for the next page to load, and then I have to go click on my profile, and then I have to go to edit my profile, and then I have to go navigate down to what my age is, and then start editing that. That is a lot of extra steps that's thrown in there. And it's very, very easy for us to write those tests. It's very, very easy for us to throw those in. But at a certain point, I'm sure you've all reached this, you no longer have 5, 10, 50 tests that you're running. You probably eventually get to hundreds, if not thousands of tests. And all of these extra steps really slow things down and make things a lot more painful. And so instead, what I suggest is you really try and follow a basic pattern, which can be incorporated within your page object model or these other patterns I'm going to be talking about afterwards. But it's this arrange, act, assert pattern. And normally if we were in person, I'd ask if anyone's familiar with it. But there's no way, I don't think, to show hands. So I'm just going to assume that some people are, some people aren't, which is totally fine. But the arrange, act, assert pattern is a well-established pattern for unit testing. It's something that developers have been using for a very long time. And it's actually one of the things that, by the way, just to mention, I said I started out as a tester and I started automating. I had no formal developer training. I went to school to be an electrical engineer. I kind of programmed as a hobby as a kid and just kind of fell into it when I started doing testing, and I realized, hey, programming would make this easier. But the more that I learn about testing and the more that I learn about writing robust tests, the more that I realize we should be copying what developers are doing, their patterns, whatnot, because they've been writing code a lot longer than we have, been writing automated tests, and their patterns really fit well for what it is that we actually need to do. So this is one of their patterns that I really kind of like to borrow and pull into my functional testing as well. So as I said, the arrange ASSERT paradigm, it's a well-documented pattern for organizing your unit tests. And I have finally started to see it growing a bit to slowly kind of becoming more of a standard for functional automated tests. The idea is your arrange step defines all of your inputs and all of your other preconditions. This might involve creating data that the test needs, such as an active user in the system. It might even mean setting up the system, such as logging in the user, navigating to a particular page, like I mentioned earlier. The act step is really going to be exercising the feature under test, or your subject under test, like I mentioned earlier. This is ideally one action, so that the result can be easily determined to be caused by the action. And then any failure triage becomes relatively simplistic. As soon as you have multiple actions and you don't get the expected response, you then have to consider, well, which of my several actions actually caused this? I mean, yes, there's still a bug, but ultimately as testers, we should care more about just, is it working right? But we should care about what's not working right so we can actually help assist fixing the application. And so by limiting our actions, by limiting those steps, it makes it much, much easier for us to figure out what was the actual cause of this. And then finally have your assert. And this step validates the results of the act step. This, again, should ideally be a single assertion, and it should be based on the observable outcome of the function being tested in the act step. And so to support the robustness and quickness of test execution, what you really should be doing is limiting the user interface interactions only to your act and assert functions of the test. And so really your goal should be to differentiate setting up the system and performing actions for validation. Your actions may need to occur and be verified at both the API and the UI level, but really there should be absolutely no need to set up your system state through the UI. And the verification then of these actions, they can be done separately. So what I mean by that is I should not need to have to log in to my application 1,000 times through the UI if I have 1,000 different tests. I should probably have, I don't know, 5, 10, maybe even 50, depending on how complex my application is, tests that actually log in through the UI and verify all those different aspects. Once I'm confident that the login through the UI works, why should I ever go revisit that again? It is a slow, painful thing to have to do. Why not use the API to actually log in? Make an API call, provide it your username and password. In the response, figure out what the token is, whether that's a bearer, whether that's a cookie, whatever it actually happens to be. Extract that out, shove it into your browser, and immediately jump to the page that you need to go to. And just to give you an idea of what this can save you, an application that a WordPress application that I was working on, it was probably almost a year ago at this point. But it took, I was able to save about just under 45 seconds on every single test by switching the login from the UI to an API. And we had a lot of tests, which meant that overall it was hours worth of time that was shaved off our execution. Again, that was a tremendous amount of savings just by having our arrange go through the API instead of through, and again, this is just the login, go through the API instead of the UI. And so, when you're testing at this UI level, you really want to be careful to differentiate your needs of what needs to be actually set up in the system and what actually is an action that needs, or an operation that needs to be verified. Again, you always want to make sure that your operation should be carried out at the UI level, but again, you really want to be thinking about any steps that can possibly be done through a different level. And again, it doesn't have to be through the API in order to get the system into the desired state. And this is not simplistic. Both the recognizing and the actual designing things in order to make sure that you don't always go through the UI, but it is going to save you a lot of time in the long run. And it's going to make your tests execute much more rapidly, but it's also going to have your tests be a lot more deterministic and a lot more reliable. Because a lot of times what I found, and I know other people have found as well, is one of my tests failed because it just took a little bit too long for this one particular element to load, which had absolutely nothing to do with the subject that I was trying to test out. And so what I'll do is I'll just rerun the test. And that's just a painful state to be in, because and I won't get into it too much, but you're setting up all sorts of really bad precedents. And so instead, what you can do is just immediately shortcut and jump to what you need to be testing. Another big aspect of that is not just can you shortcut it and get rid of skip out on buggy code, but let's say that your UI for the login isn't completed yet. Then maybe I can't run all of my tests, or even worse, maybe your login UI has a bug in it, and that's preventing you from running any of your other tests. Well, if the login API is working correctly, who cares if the login UI is working or not? You can pretty much completely bypass it by logging in and authenticating at a lower level, and then moving on to your other subjects under test. Again, you have tests that are testing the login. You can raise that bug, but then you can move on and test other things. There's no need to have these kind of cascading failures of one part of the system blocking the other. And so with that, I want to move on to an example. This is our Cucumber Arrange Act Assert example. So given I am authenticated as a read-only user to my site, when I log out, then I see the login portal. And this is, very, very clear. I like using GHERKIN because it very easily distinguishes the Arrange Act Assert, where my arranges are my givens, my whens are my actions, and my thens are my assertions. And when you break things down like this, when you think about it, you say, all right, given I am authenticated as a read-only user to my site, sure, I need to have a user that exists, and it has to be a read-only user. And I need to be authenticated. Well, I can do both of those without doing anything with the UI. So that's easy enough. When I log out, it just means I need to be probably on a particular page, and then I need to click the logout button. Those seem like two actions that I can do fairly easily. And then I see the login portal. Again, that is something that I can easily verify through the UI as well. So what that would look like on the back end, this is again a little bit more Java for our implementation. We have our public class, my steps. This is a fairly basic Cucumber setup. Given I'm authenticated as a read-only user to the site, I'm going to make a REST. Oops, sorry about that. I'm going to make a REST call to my login URL, and I'm going to pass in some JSON of my username and my password, which, of course, super secure password that I have right there. And then I'm going to go to my home URL, meaning that I am authenticated as a read-only user that I already know exists in my system. Two very, very easy commands in order to make. And this REST.post call, what it actually does is it makes the call, grabs a token, stuffs it into my browser object. Stuffs it into my driver object. When I log out, all I need to do is call my homepage.logout. Very simple, very few amount of steps. And you can see that I've completely broken out my UI through my API. And yes, this is actually from using a similar model to what we were looking at before, because this homepage is actually the same homepage page object model that we were looking at. And that's one of the really nice things about page object model, about the Arrange Act Assert pattern, is that you can use it with the page object model, you can use it with SCREENPLAY, you can use it with application actions, all these things that I'm going to be talking about further on. It's the overall kind of pattern that you want to be thinking about that should be driving your overall design. So I want to talk about two other patterns with the rest of the time that I have today. Before I do, any questions on Arrange Act Assert? All right, I see Jonathan shaking his head and no one else is coming off mute. So I'm going to go ahead and keep going. So I like to talk about these two patterns because for the most part, when I ask people about test automation, frameworks and patterns and whatnot, page object model usually comes up. And I very rarely hear anything about other patterns. And even though some of these have been around for a long time, and even when I ask people about, well, what problems do you run into with page object models, sometimes they'll come up with some of the issues that I've just mentioned. And, you know, when we try and talk about solutions, I don't oftentimes hear a lot of good things. And so again, I kind of like to bring these up just to expose you to them. The sad news is you will not be an expert. You will not even be mediocre at these two new patterns I'm going to be talking to you about, you know, because we have, what, 15, 20 minutes maybe to get through these. But I do want you to realize that they're out there, that they're useful. And, you know, if you're interested in them, go out and learn a little bit more about it. And so the whole idea about the application actions design pattern is that you're really supposed to be switching from page objects that always go through the page's user interface to actions that actually control the application via its own internal model API. And when I say API, I don't necessarily mean its REST interface. I mean the actual kind of underlying API that drives the system itself. So the applications action pattern is something that has been made really popular with Cypress. And if you actually want to find out more information about application action, Cypress has a whole ton of interesting reading about it. That said, it is absolutely not just something that can be used in Cypress. What it does is it allows you to control your application at a lower level than the UI. And again, you want to be doing that for all of your arrange steps. When it comes down to your act and your assert, you still want to be doing things the normal way. But if you're trying to get your system into a desired state, well, rather than having to go through the UI or maybe even make a REST call, there are a lot of other things that you can actually do. And I'll show you some examples of those. But your tests, as a result, they become a lot faster. You know, even your simple MVC tests that may be running locally against whatever browser, you can usually, just like I said before, you know, I was able to shave off 45 seconds. In Cypress, I've been able to drop my test time by like a minute each for each test when you start really using the application actions pattern. And, you know, I'll usually see anywhere between like a 50 and like a 75% increase, which is huge. But if you think about it, that makes sense. You waste a lot of time going through the UI for a lot of things you really don't need. And so that, again, really benefits things. And so the idea is if you think about something like, again, and I'll use Cypress for this particular example, but if you think about it, your JavaScript application within your browser itself and everything, you know, running with JavaScript, rather than actually clicking on a button, well, why not just call the JavaScript.click action on your particular element when you find it, rather than going through the UI? If you don't care about testing that particular element in this test because you have tested it elsewhere, why not shortcut through it? But rather than just calling, you know, say a click method on a particular element, what you can actually do is go a whole lot further, because the developers have written all of these back-end commands to perform all of these actions that, you know, happen once you click on the UI element. So you can do more than just kind of do a JavaScript, you know, click on a particular element, but you can actually call the same commands and the same methods that they would in order to set up a particular, sometimes complex methods, whether that's creating users, creating new elements, deleting elements, etc. And as a result of that, what you get is this really nice cycle. Because not only are your tests testing the application, but they're also verifying that the application code is efficient and effective. And as a result, your code, if assuming that you actually have access to both these, can become a lot more reasonable, more sensible, and it will be a lot better documented. Again, because the interface that you're actually using in order to make all these commands is being exercised by both your application and your tests. And again, as a result, it becomes very easy to write end-to-end tests for them. And another huge added benefit is you really avoid writing, kind of this loosely coupled layer of code on top of, on top of the UI, basically on top of your unstable user interfaces. And instead, your tests are going to use the much more robust and your much more longer lasting internal model of the application itself. Again, I've been showing examples this entire time because for me, I read about applications actions and I said, all right, I think I get it. And then I looked at some code. I'm like, all right, I now have a better idea. But then I actually started writing some of it. And that for me was when it really started to click and really started to make sense. So I have an example for you all for the applications action. This is actually in PHP. As I said, it's a big Cypress thing. If you're doing JavaScript, you'll see it all over. But I wanted to kind of point out that you can do this in other languages as well, which of course was why, I asked at the beginning of this talk, who's using what frameworks, who's using what languages, just because I'm kind of curious as to, am I making good choices or bad choices with what I'm showing to everybody. So for this particular example, we're doing stuff in PHP, and this is actually about deleting an album. Well, if you think about it, if you're going to be deleting an album, the very first thing that you're going to need in your arrange is you're actually going to need an album that you're able to delete. So rather than going through the UI to create an album, which in this particular application isn't a nightmare, but it can take 2 or 3 minutes because you have to log in and authenticate as an admin user. You then need to navigate to the correct page. You need to create your album in general. Then you need to upload images to your album, save all of that off. And then, of course, you need to log out so that then you can log back in as the user that you actually want to test things with. Rather than, so you can actually, test deleting the actual album with, whatever user you wanted to. But rather than doing all of that, what you can actually do is you can call these backend methods. So for things like JavaScript, for things like PHP, if you keep your application test code in the same repository and structured properly as your application code, it's very easy in order to refer these exact same methods. So rather than going through all those steps that I just mentioned, instead you could just create your new album by declaring new album, title, date, description, whatever else we actually need in there. And that is going to do all that setup that I just mentioned in one very quick, nice line with, that's very readable. And at that point, you can do whatever you actually need. And of course, at the end, in case you delete it or you don't delete it, etc., your cleanup becomes extremely simple. You can call your this album delete. So even if you don't have a CRUD interface for your REST or SOAP or whatever APIs you actually have, your typical web APIs, you can still actually get this create and get this delete done all through your actual system kind of backend calls, essentially. And again, it makes things extremely fast, and it also tests out the lower level code. Now, the disadvantage to this is you do have to have some sort of insight into your application. You obviously can't do this with black box testing because you need to understand where these methods are, how you can call them, how you can interact with them. That said, once you have that information and you're able to do it, you can write much quicker tests, and you don't have to do all this implementation. The developers have already done it for you. You just find out how you actually create or how you manipulate the system, usually by having a nice conversation with the developer, and you can go ahead and call these actions and speed that up tremendously. Any questions about applications action? And this is usually where I get a whole bunch of questions. So please feel free, speak up before we jump on to the next pattern. All right. So that means I've completely confused and lost everybody, or I've done a perfect job of explaining it, and I'm going to assume it was the latter. But Jonathan's face seems to tell me that's not accurate. So the last one we're going to talk about tonight is the screenplay pattern. So the screenplay pattern is often also referred to as the journey design pattern. And basically, the whole idea is it's supposed to really be looking at the solid design principles and trying to build a testing design. Really, Screenplay is much more of a framework if you really look at it, but trying to build that around those. For those who are not familiar with SOLID, it's a mnemonic acronym for 5 design principles, which are really intended to make software designs more understandable, flexible, and maintainable. And the idea is S is SRP, single responsibility principle, like we talked about before. A class should only have a single responsibility, meaning it only changes one part of the software specification, which should be able to affect the specification of the class. The O is for open-close principle. Software entities should be open for extension, but closed for modification. The L is for Liskov substitution principle. Objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program. The I is for interface segregation principle, which is basically many client-specific interfaces are better than one general-purpose interface, which is extremely important. I always like to point this out because a lot of times, as I mentioned, the page object model, you get these conditional methods of trying to kind of handle absolutely everything, and this is exactly what you want to avoid. You want multiple specific interfaces rather than just one generic one with a whole bunch of conditional statements, your general purpose. And then finally, your D is your dependency inversion principle. And that's basically you should depend on abstractions, not concretions. And I'm aware that throughout this entire talk, I've mentioned all sorts of fun, what my wife refers to as boring computer jargon. But I also mentioned earlier that, again, we, as testers, we're better off making use of good developer patterns that have been established, that are shown to make things more effective, because that's going to make us better testers, and it's going to make our tests much more reliable and much more solid. And so the screenplay pattern, to get back to what I was talking about, the screenplay pattern, it tries to address the issues and the challenges and solutions that eventually you're going to encounter when you're developing your UI test automation. Basically, as soon as you create the page object pattern, you're going to be facing challenges basically as far as organization goes, as far as arranging the code, as far as your different languages, whatever. And so this is really meant to be, if you were to continue to refactor what you would actually see from your page object model, following solid design principles, which is incredibly usually complex, takes a lot of time, and most people will never do it because it works enough, and technical debt for testers isn't really something that we ever think about. But if you really did that using solid design principles, what you'd end up with, at least from what the screenplay folks claim, is the screenplay pattern. I think you'd end up with something pretty close. I'm not 100% certain I agree with that. But I do agree that it makes things, once you wrap your head around the paradigm, much simpler to run through. So as I said, the screenplay pattern is also known as the journey design pattern. And the whole idea is it focuses around an actor-centric model with tests that focus on how a user interacts with the application to achieve a goal, as opposed to kind of how a page is used. So rather than focusing on how I'm going to be interacting with an element, I want to figure out, Max as the user, what am I trying to do? Am I trying to, buy cake on a site? Am I trying to send someone a message, etc., rather than looking at the lower level individual elements? So, the main thing that I really like about the screenplay pattern is it really reduces down the complexity of what you'd actually be looking at for your page object model. Like I've seen, and I think I mentioned this before, but I've seen huge files with 500 lines just of identifiers and actions, and they're all in one place, which means you get duplications. You have unused page objects. You don't immediately you don't immediately know if changing a page object is going to break other tests. You don't know what's shared, what isn't shared, and these things get really complicated and painful. And so instead, if you really focus on what it is that you're trying to accomplish, what your end user is trying to accomplish, you can eliminate a lot of what I'll call verbose code. And so what you get is you have an actor, and all these actors, they have different abilities. And each of these abilities then enables a user to perform different actions. The actor also performs tasks. These tasks are also made up of actions. And so then what you have are your actions and your questions then that interact with your elements, as opposed to your tests doing those directly. And again, what you get is a whole bunch, I'll say more classes, but less code and much simpler code, and something that overall is much easier to actually follow. So here's a typical JS screenplay example. And this is, again, from another application that I've actually was using Protractor in order to test. And this doesn't dive into all of the complexity of it, but hopefully it kind of gives you an idea. So up here, what we've actually done is we've created an actor. And all we've said is anytime that I want an actor, return someone who can browse the web using Protractor. So any single time I refer to an actor, this is what I mean. That's all that I actually care about. And so my describe basically for is my suite of tests. And what I'm saying is before every single test within it, I'm going to need a new actor. So this is exactly what I'm doing. I'm going to be engaging my actors. So if I wanted to verify that a user can actually log in, I'm going to get an actor called Max, which I'm getting again from these actors up here. Max is going to attempt to launch the app, which is another method that I've defined. So this is an action. So Max is going to launch the app. Launch the app then is defined as actually taking this Protractor browser and launching it. Max is then going to log in. And again, this is another action which is defined elsewhere. And then I'm going to ensure that these are my assertions. We actually have tests, I'm going to ensure that we actually have text that says welcome, the welcome user text, and that it equals Max. And so again, it takes a little bit of getting used to, and you really kind of need to dig into this before the screenplay. For me, I think I had to go through this more times than anything else in order to kind of get a great understanding of it. But the idea is you've really separated out your users from your actions, from your implementations, which overall makes things a whole lot simpler. And for me, what I really like about the screenplay pattern is it allows multiple people to kind of get involved in the testing at a higher level. So for example, if you use personas, this fits in perfectly with this whole idea of having different personas, different users who may be performing different actions, who may have different questions, who may have different desires, who may be doing different things. I mean, that works really, really well within this screenplay pattern because you can take those personas, you can define them exactly like you'd expect. For example, you have an actor who can browse the web. You may have another actor who can, only has read access. You may have an actor who has write access. And so you can define all of these things based on your personas and then write your tests based on those. So, whether those are your RBOC tests or not. And with that, it's pretty much all that I wanted to get into. As I said, we kind of get deeper and deeper, and I save screenplay for the end because it's, I think, the hardest one to really get into. But the main things that you want to be thinking about, speeding up your tests as much as you can by using the API. Now, whether that's your RESTful interface, whether that's your application's backend API, you want to be kind of throwing those out there. The next two I always throw in no matter what automation talk I'm giving because I think it's always really important just to make sure your tests are independent, make sure that you can parallelize them, and making sure that whatever design pattern you're using supports these. You only want to automate the UI where it's really necessary. The big thing is you want your application, you want your test code to be maintainable. The thing that I usually repeat when I'm talking to my testers is you have to remember that test code is code. It has to be treated as code, which means it has to be maintainable. It has to be reliable. All of those things that you'd expect from the application itself. And choosing the right pattern is really going to help that be the case. You want to be remembering all of your, whatever design patterns, principles but the big thing, I mentioned this a lot, you really don't want to be reinventing the wheel. You want to not just be keeping things simple because this is how you've refactored, but look at some of those other design patterns that are out there that exist and see if they can actually help you out. And with that, I think I'm pretty much out of time anyways. So any questions?
Hi, my name is Viswa, and I have a question. Probably not related to your presentation, but so we have an application where we need to test something like publish subscribe model, right? Where user A is a publisher and there are multiple users, B to Z, who are actually subscribers. So when somebody publishes when basically a publisher publishes, we have to make sure that all the subscribers get that information and that the information is right. So in this, I'm trying to figure out if there's a particular design model that will fit this scenario, or if there's, how do I implement has been my biggest challenge with this model.
Without knowing, I would say that any of the patterns that I went through, any and all of them can apply for it. It sounds like if you're trying to figure out, if one of your users publishes something, do the rest of them receive it properly? I would probably say that it really sounds kind of like this arrange at the cert pattern where you're not really testing that they can publish something. You're really testing is can everything receive it? And you probably have other tests just for the publishing. And so to really, again, I think any of these patterns can make good use of this, but, just thinking about how you can use your system in order to simulate and speed up a lot of those things. I don't know if that answers your question or not, but I guess, again, I think all of these patterns any of these patterns could really be applicable for you.
Okay, thank you.
Again, everyone, for attending, and I look forward to seeing you at a future meetup.
All right, thanks for hosting this, Jonathan.
Thanks, Max.
Thank you.
Jonathan.
Thank you.